Our metals experiment, our alkali metals experiment, I am going to use an indicator. It's a green indicator to show the pH change, okay? And I'm going to start my test with lithium. So, if we have a little look at lithium, you will be able to put down your results, what lithium actually looks like. So, if I just chop it up, I'm just going to make this safe, I don't want any more reacting with water. I just chop this up and we get a little zoom in on what it looks like. Very shiny. Okay?
Okay, for the camera.
Very shiny. Very shiny on the inside, you can put that in your description. Alright, and it stays quite shiny, it's not reacting with air a lot. Even when I dampen off the oil that is securing it in suspension from water so it doesn't react. And now guess what's happened as soon as it's hit the air? Who wants to have a guess? Yep.
It's gone dark.
It's gone dark. It's gone dark grey. So it's reacting with air. You can put that in your description. Are you ready for this?
Yeah.
Okay, we're going to go for reaction in water of lithium in 3,
2, 1, go.
and we have a fizz. We have some gas and some bubbling going on.
And it's like moving.
It's moving, correct?
Gas coming in here.
Yeah, there is some gas for that. So our next one is?
Sodium.
Thank you, sodium. Now, sodium is again very similar in shape and size and the way it looks to our original lithium. And if I dab the oil off like I did earlier, as soon as I cut it, we are going to notice something. What do you reckon we'll notice straight away?
Shiny.
Shiny. Yep. Okay, not as shiny, I don't believe, as the lithium, but that is a piece of qualitative data. That's me making an assumption about something, not quantitative. Quantitative is a number, isn't it? And you wanted a number about pH. We can't give that. So we haven't got an indicator strip to give a number, but we have got what we believe it looks like. Now I'm going to put the rest of that back in oil, and I'm going to dampen off the oil so it will react. Now, as I dampen off the oil, something's going to happen to the silver. What do you think is going to happen?
It's on grey.
It'll turn grey, and that's not turning as grey originally. That might be down to the oil or a number of things. I'll just dampen it off a bit. It is greying off, but not as quickly. Cover that up. Okay, and we're going to react it with water now. So can I have a 3?
3, 2, 1.
Now we're getting more of a reaction, and it's actually turning itself into a ball, a pea. Lots of heat, lots of alkali indicator being shown here. Very quick reaction, lots of gas. I can even sort of get a whiff of that, and tons of heat. And why am I keeping it away from the outside of the bowl? Why do you think? Yep.
It's because of the heat, it might like.
Yes. And it's quite dangerous what I'm doing, keeping it away, but I would like my bowl to remain intact, so I'm keeping it away. And we're now down to a very small ball bearing size as it continues to react. There we go. Can you see it? And again, we have a very strong alkali solution. Yes?
Why is it?
We're going to work on our, what you predict is our most reactive, potassium, because you said it was lower down in the periodic table, which is good. I'm going to use a very small amount because I do get wrong for using a lot of this all the time. It's expensive and also very reactive. I'll start with a small amount. We'll see how it goes. Anyone want to make a prediction about what we're going to see? Yes?
It's all going to like bubble up.
It's going to bubble up. We know that's going to happen. Does anyone know what other sort of energy might be shown, dispersed, doing this? Yep.
Heat.
Well, we got heat already.
Funny.
Foamy energy. I've not heard of that one. We've got smoke, we've got heat.
Light.
Yeah, light. So, again, very silvery, very, very soft. Here we go. Let's have a 3,
2,
1.
You do like that little? Did you see that little hoop of smoke? Okay, that is it because it was a smaller man. We've got to keep it a smaller man.
Yeah.
And ensure that we don't use too much. But I do want to just show you what the inside looks like. If I cut a sliver, it's quite sparkly. Looks a bit like a precious stone or like something you'd use as jewellery. If you have a look here, I can bring it and show you. It's got a bluey tinge to it. And as it hits the air and I dampen off the oil again, you'll notice what happens. It's even gone more blue, look. Quite cool. What do you notice about the metal? What's going on with the tweezers? Look, it's already going
Blue.
squidgy. So that means it's very soft. Can I have a 3?
2, 1.